Hey everybody, this is our Limits and Derivatives video 7 on power rule. Let's get started. Alright, so you're going to find the derivative of f of x equals x squared plus 3x minus 5, and we're going to be using that long definition of the derivative. So let's just give it one try, and then I'm going to show you a shortcut for this that is under the understanding called the power rule. So let's give it a try. First thing, we have our definition of the derivative, which is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Let's go ahead with our substitution. So the limit as h approaches 0 of x plus h squared plus 3 times x plus h minus 5 minus the original function x squared plus 3x minus 5 all over h. I'm going to go ahead and do my expansion on that binomial that's being squared. X squared plus 2xh plus h squared. Distribute the 3x plus 3h minus 5 minus x squared minus 3x and plus 5 all over h. We get to eliminate the like terms, which happen to be x squareds, happens to be our 3x's and our 5, leaving us with the limit as h approaches 0 of 2xh plus h squared plus 3h all over h. The next step would be to factor out a common factor of h so that we can eliminate the issue in the denominator, leaving us with 2x plus h plus 3. And finally, I get to substitute in the 0 here, which leaves us with f prime of x equals 2x plus 3. So remembering that our answer should be 2x plus 3, let's look at the next slide where I'm going to show you how to do this in a matter of seconds. Alright, so now we're going to apply the power rule. And our power rule involves powers, as in exponents, not superpowers. So I'm going to be focusing on my exponent for each of these. So I'm going to rewrite my function a little bit bigger so I can, explain it to you. So I have x squared plus 3x minus 5. And I'm going to fill in here in a different color some exponents. So I'm going to put a 1 up here, and this is going to be x to the 0 power because anything to the 0 power is 1. Alright, so moving on from that, I'm going to then take the exponent and bring it down in the front. Well, actually I'm multiplying it by the coefficient. So 2 times 1 is 2. Put my x there, and then I'm going to subtract my exponents. So 2 minus 1 is 1. The next thing I'm going to do is the next term. So 1 times 3 is 3. And then I'm going to subtract, and I get x to the 0, so I don't want to write that. Then I'm going to take 0 times 5 is 0, so that's gone. So my answer is f of x equals 2x plus 3. Now that was only one example, so let's try another one and maybe you'll catch on. Hopefully you'll catch on. Okay, so the idea is that we take the exponent and multiply it in front. That's 24x. We want one less exponent, so it's 5. Take the 2, multiply by a negative 3, you get negative 6. I want one less exponent. That's 1. Take the 1 that's really here, multiply it by the 6, and we get a 6. And then if I subtract, I get no x's. And of course, this has nothing, so I don't get anything else. So my first derivative is 24x to the 5th minus 6x plus 6. Number 4, 5 times negative 2, and then I subtract an exponent. 3 times 4 is 12, subtract an exponent. 2 times negative 5 is negative 10, subtract an exponent. 1 times 7 is 7, subtract an exponent, and the constant disappears. There's number 5. Number 4. Number 5. 10 times 11 is 110x, subtract an exponent. 12 times 54, you can do that on your own. It is, I'll do it. 12 times 54 is 8 and 10 and 4 and 5. 548. 548x, subtract an exponent, it's to the 11th power. 3 times negative 15 is negative 45, x squared, because I'm subtracting an exponent. Review those examples, look carefully at the pattern between the exponents and the coefficients. Once you find that pattern, you've got the power rule. Great job.